Welcome back to the Data with Srini. Today we are learning SQL views. Our opening business question is simple. The CFO wants the same weekly provider report every Monday. We could keep finding, copying, and rerunning a long SQL statement. A view, let us give that useful query a permanent database name. But I want to establish something at the beginning. We do more than save us from retyping SQL. A well-designed view can become a stable business-facing layer over complex tables. It can combine data from multiple tables. It can expose only the columns users need. It can hide complicated joins and calculations. It can standardize business definitions. It can simplify reporting and dashboard queries. And together with the database permissions, it can help control how users access underlying data. So our beginner definition is a view is named reusable select query that behaves like a virtual table. Our deeper professional definition is a view can act an abstraction layer between a raw database structure and the people reports or application that consume the data. We'll start with a simple idea and gradually widen our horizon. One important sentence remains true for normal SQL Server view. The view stores the query definition, not a separate copy of all the result rows. Later in this lesson, I will also briefly explain indexed views because they are an important SQL Server exception to the simpler beginner's mental model. The obvious reason for a view is reuse. Without a view, someone may find last week's SQL, copy it, edit it, and run again. That creates more than inconvenience. Suppose three analysts copy the same provider report query and each person changes it slightly. One includes denied claims, one excludes them, one changes the date filter. Suddenly the organization has three versions of what everyone calls the same metric. A view can centralize that logic. Instead of every report defining provider total independently, reports can consume the same approved view. That gives us consistency. Views also provide abstraction. User may not need to understand that a report joins claims, providers, hospitals, insurance plans, and several lookup tables. The view can present a simpler shape such as provider ID, provider name, claim count, and provider total. This is similar to creating a clean interface or complicated implementation details. Views can also support controlled access. For example, a reporting view might intentionally expose member ID, age band, and risk category, while leaving more sensitive columns out of the view. Actual security still depends on SQL Server permissions and the database design, but the view can be part of that access strategy. So views exist for at least four major reasons. First, reuse. Next, consistency, abstraction, and controlled presentation of the data. That is much bigger idea than merely I don't want to type the query again. Let us make the architecture precise. A normal table stores rows. A normal SQL Server view stores a query definition. When we select from the view, SQL Server uses the definition as part of the query. It executes against the underlying objects. That's why we call a view a virtual table. To the consumer, it has named columns and can appear in from class much like a table. But the result rows are normally not stored as a separate duplicate data set just because we created the view. The distinction matters. If claim changes, a normal view can reflect the new claims data the next time the view is queried. Now for the wider horizon. SQL Server also supports indexed views under specific rules. An indexed view is more advanced feature where SQL Server can physically persist indexed results. That is not what we are building in this fundamental lesson, and indexed views have an important restrictions and maintenance costs. So when I say view stores the query, not the data, mentally add for the normal views we are learning here. Professional takeaway, table is equal to stored data. Standard view, stored query definition, presenting virtual table results. Index view, advanced SQL Server feature with physical indexing under specific requirements. When we run select star from VW weekly provider report, SQL Server does not normally perform a separate step that says open a saved result file. Instead, view definition becomes part of the statement SQL Server has to optimize. Conceptually think, your select references the view. The view represents another select. That select references the base tables. SQL Server optimizer determines an execution plan for the overall request. This matters because a view does not automatically make a complex query cheap. If the view joins millions of rows, the work still has to be done according to the execution plan. A view simplifies how we express and consume the logic. It does not magically remove the underlying work. Now consider freshness. A new claim is inserted into the claims table. For standard view, we do not manually refresh a stored copy. When the view is queried again, the query works with the current underlying data visible to that statement. This is one of the reasons views are so useful for operational reporting. But remember that current is still subject to normal database realities such as transactions, isolation, data loading schedules, and what has actually been committed to the base tables. This is the professional version of the beginner statement. Views return current data from the underlying tables. The create view syntax is intentionally familiar. Create view schema and view name as then a select statement. The power comes from what that select can represent. A view can join tables, it can filter rows, it can calculate expressions, it can use case when, it can group and aggregate. It can expose aliases that are easier for reporting users to understand. There are also restrictions. For example, a view is not simplify a place where every possible select syntax is allowed without rules. SQL Server places restrictions around constructs such as order by in view definition unless used in permitted context such as top or offset. And even then, you should not rely on the view itself to guarantee presentation order. This leads to a very important rule. Tables and views represent sets of rows. If the consumer needs a guaranteed order, put order by in the select that consumes the view. Also notice the schema prefix DBO. Using schema qualified name is a good professional habit because it makes object ownership and references clear. Finally, choose view names that communicate purpose. VW underscore weekly provider report tells us for more than view 1. Naming is part of maintainable database design. This slide shows the developer side and the consumer side. On the left, a developer creates a view. The SQL may contain joins, group by, calculation, case logic, or other approved business rules. On the right, the consumer gets a much simpler interface. Select from dbo.vw weekly provider report. That consumer could be another SQL developer. It could be analyst. It could be a reporting tool. It could be a dashboard. It could be an application, depending on the architecture. This is why I like to think of view as a data contract or interface. The underlying database may be complicated, but the view promises a useful set of columns with defined meaning. For example, provider ID, provider name, claim count, provider total. If many reports depend on what interface changes to the view should be made carefully because downstream consumers may depend on its column names and meanings. That introduces an important professional concept, dependencies. Views make consumption simpler, but once the other objects and reports depend on a view, the view becomes part of your data architecture. Reusable does not mean consequence-free. It means we have created something worth managing deliberately. Our Dr. Adams example demonstrates the normal behavior nicely. A new claim is inserted to the claims table. When we query the view again, Dr. Adams provider total reflects the underlying data according to the view logic. No separate refresh of a changed view is required. Now let us widen the horizon. A view depends on its underlying objects. If the view references claim.claimAmount and someone changes or removes that column, the view can be affected. This is why database changes need dependency awareness. It is also one reason experienced developers are cautious about select star inside long-lived views. If you explicitly list the columns the view is meant to expose, the view's contract is clear. Instead of select star from claims table, prefer intentionally selected columns when designing a reporting view. That gives you more control over what consumers see and makes the view purpose easier to understand. SQL Server also has features such as schema binding for advanced scenarios. Schema binding ties a view more tightly a referenced schema objects and is required for indexed views. We do not need it for today's basic view, but you should recognize the term when you encounter production SQL. The fundamentals principle is simple. View depend on base objects, so design them intentionally. This slide is where the whole fundamental series starts connecting. A view can package many of the SQL skills we already learned. Joins combine related tables, where defines row level filtering, group by changes the grain and creates summaries, having filters grouped results, case when translate raw values into business categories. Subqueries can provide dynamic logic. A view can package those decisions behind a stable name. Imagine a view called VW provided performance. Behind that name, the SQL may join providers and claims, exclude irrelevant claim statuses, group at the provider level, calculate totals, and classify providers into performance bands. The person consuming the view does not need to reproduce all that logic. This is sometimes called an abstraction layer. And in analytics, you may also hear related ideas such as semantic layer or curated reporting layer. A SQL view by itself is not complete enterprise semantic layer, but it can absolutely serve as one building block. This is powerful because raw operational tables are often designed for transactions and system integrity, not for easy reporting. Views let us reshape those structures into business-friendly data sets. So the view can translate database structure, business-facing structure. That is one of the biggest real-world reasons views matter. Let us explain our list of practical use cases. First, reusable reports and dashboards. If multiple reports need the same provider level data set, a view can centralize the SQL. Second, hide complexity. A consumer can query one view instead of understanding 10 joins. Third, consistency. If provider total has an approved business definition, put that definition in one managed place instead of copying into every query dashboard. Fourth, simpler access. A reporting user may work with a view without needing to understand the entire transactional schema. Fifth, controlled column exposure. A view can expose only the columns appropriate for a particular audience. For example, healthcare analytics view may expose de-identified or business relevant fields while omitting columns that consumers do not need. Again, the actual security model requires correct grant, deny permissions on database. Ownership configuration. Merely creating a view is not complete security solution. Sixth, compatibility and installation. Suppose the underlying schema changes, but an application expects a familiar column structure. In some designs, a view can preserve stable interface while underlying implementation evolves. Seventh, reusable derived data. A view can expose calculated columns, normalized labels, joined descriptions, or aggregate matrix. Eighth, simplify application and BI queries. Power BI reporting tools, applications, and analytics can consume a curated view rather than rebuilding raw table logic. When should you not automatically create a view? Do not create one for every trivial select. Do not create layers of views on top of views without understanding the complexity. And do not assume a view is a performance optimization. Use a view when it creates a clear, reusable, governed interface to data. Let's go beyond beginner mistakes. Mistake 1. Thinking a standard view stores a duplicate copy of all result data. It normally stores the query definition. Mistake 2. Using vague names. A view should tell us what business data set it represents. Mistake 3. Putting unrelated responsibilities into one view. If one view is simultaneously trying to be claims detailed dataset, a provider summary, a member eligibility layer, and a finance reconciliation report, it may become difficult to reason about. Mistake 4. Ignoring dependencies and permissions. A view depends on underlying objects and access behavior depends on SQL Server security configuration. Now, several additional professional mistakes. Mistake 5. Assuming order by inside or around a view means consumer will always receive rows in the order. The consuming select should specify order by and order matters. Mistake 6. Using select star casually is in a long-lived view. Explicit columns make the interface clearer and reduce surprises when schema evolves. Mistake 7. Assuming views automatically improve performance. A complicated view can still produce an extensive execution plan. Mistake 8. Building view on view until nobody understands the underlying work. Layering can be useful, but excessive nesting can make troubleshooting and performance analysis difficult. Mistake 9. Changing a widely used view without considering downstream reports or applications. Once consumer depends on a view, column names, data types, grain, and business definitions effectively become a contract. Professional takeaway. A view simplifies access, but the view itself becomes an object that deserves designing principles. Now create one view, VW provider claim summary. The required output is provider ID, provider name, claim count, provider total. You already know the SQL concepts. Join claims to providers, group at the provider level, count the claim counts, sum claim amount. But before writing SQL, answer two architecture questions. Question 1. What does one row in the view represent? Answer: one provider. That's the grain. Question 2. Why this result worth turning into view? Because it has a clear reusable business purpose. A dashboard, analyst, or weekly report could query the same provider summary without rewriting the aggregation. That is how I want you to decide whether something deserves to become a view or not. Can I put this select in a view? But does this select represent useful, stable dataset that other work may benefit from? Pause the video and build it. Then test the view with simple select. And as a bonus, try adding an order by to the consuming select rather than expecting the view to define presentation order. Let us finish by widening our definition of view. At the syntax level, a view is named select query. At the usage level, we can query it like a virtual table. At the architecture level, a view can become a reusable interface between complex database structures and the people, applications, dashboards, or reports that consume data. Views can help us reuse SQL logic, hide complexity, standardize business definitions, reshape transactional data for reporting, expose selected columns, simplified BI and application queries, and provide stable interface in some database designs. But views also come with responsibilities. A standard view is not automatically stored a copy of the result. A view is not automatically faster. A view depends on underlying objects. Permissions still matter. Ordering must be requested by the consuming query. Long-lived views should expose deliberate columns and stable business meaning. And there is an advanced horizon. SQL Server supports updatable views in certain cases, meaning some insert, update, or delete operation through a view can affect underlying tables when SQL Server rules permit it. That is useful, but it requires careful understanding and is not our reporting focused fundamentals use case here. SQL Server also supports indexed views under strict requirements. Those can physically persist indexed results and may be used for specialized performance scenarios, but they add restrictions and maintenance overhead. These two topics are important because they show that views are more than saved reports. Even though we do not need to implement them today, now compare our three organization tools: subquery, a query nested where another query needs its result; View, a reusable database object that presents query logic through a table name; CTE, common table expression, a named intermediate result used to organize one statement. That brings us naturally to lesson 9, common table expressions. In lesson 9, we'll take complex SQL and break it into reusable, readable, named business steps. Final takeaway: do not think view is equal to save typing.